Write the rule for the nth term for a geometric sequence or series. Ooh, by the way, there should be a U in there, right? Sequence or series given two terms. So in this case, we're given a sub 2 equals 12 and a sub 4 equals 3, and we're told that this is a geometric sequence or secants, as they say. Anyways, here is the rule for the nth term for a geometric sequence. I'm going to remind you, it's a sub n equals a sub 1 times r to the power of n minus 1. Probably worth writing down again. And what we're going to do is we're going to fill in what we know. We know a sub 2 is equal to a sub 1, which we don't know, times r, which we don't know, times n minus 1. Well, guess what? Now we know n because a sub 2 gives us a 2 right there. So this will be 2 minus 1. So by the way, we know a sub 2 is 12. So I'm going to write 12 equals a sub 1 times r to the 2 minus 1, which is simply 1, which is, I don't need to write it. So 12 equals a sub 1 times r. Now, let's try this other guy, a sub 4. It'll be a sub 4 equals a sub 1 times r to the n minus 1. A sub 4, the n will be 4, so 4 minus 1. And then a sub 4 we know is 3, so we'll rewrite this as 3 equals a sub 1 times r to the third power. And so now we have these two equations that have an a sub 1 and an r in them. And what we can do is figure out what one of these things is, and then we'll either solve for a sub 1 or r, and then we'll substitute that result into the other equation. So let's go ahead and try. So I'm going to try to get a sub 1 by itself. So that's going to be over here, if I divide both sides by r, I get a sub 1, let's go ahead and use a different color, I get a sub 1 equals just 12 divided by r. These r's cancel. And so then I can go ahead and substitute this 12 divided by r over here. So this will be 3 equals 12 divided by r times r cubed. And again, beautifully, r cubed cancels with r, and that just gets us 12 times r squared. And so from this we can then go ahead and solve for whatever r is. So r squared is going to be equal to 3 divided by 12, which equals 1/4. And then we square root both sides, and r equals 1/2. Now, for those of you that are paying attention, in the past when we square rooted both sides of the equation, we'd get plus or minus 1/2, except when it comes to geometric sequences and series, the r will always be greater than 0, and it'll never be 1. So maybe we'll write that out. R is going to be greater than 0, and r will not be equal to 1. Anyways, let's go ahead and write out the rule. So we'll say a sub n equals, now we know a sub 1, it's going to be 12 divided by 1/2, which, by the way, if we do 12 divided by 1/2, that's the same as 12 times 2 over 1, so that's 24. So it'll be 24, that's a sub 1, times r, which is 1/2, and that'll be raised to the, I'll put that in parentheses because that's going to be raised to the power of n minus 1. So now we have a handy dandy rule that we could use to figure out any term in the sequence that has a sub 2 equal 12, a sub 4 equal 3, and we're told that it's a geometric sequence. Yay!